Hi, and welcome to part 3 of our chapter 14. In this part, we're going to be going over regression. So the previous part was just about correlation, how we find an R value, R squared value, and how we test for our hypothesis. So now we're going to get into regression. Now regression itself can take on a lot of forms, and it's a big part of statistics. We're not going to get into all the nitty-gritty with regression. We just want to know how it's calculated and what does it mean. We can certainly definitely go farther with regression, but for the purpose of the class, with the correlation and everything else on there, we're just going to focus on regression kind of in a more simple form. So regression describes a relationship in the data with a line that predicts the average change in y per unit of x. It's the best fitting line as found by minimizing the sum of squares residuals as shown in this figure. So here we have our blue line here, which is from our previous example with cigarettes and lung cancer mortality, excuse me. And what we're doing here is we're finding the best fitted line. So this line is the best fitted line for regression. And as you can see, regression line, the equation is y equals a plus bx. Y hat. Don't forget that's y hat. So where y hat is the predicted value of y, and a is the intercept and slope of the line, and b is the slope of the line. So what regression is telling us is if you had this fitted line and you were given a value of x, you should be able to predict with so if you had this line again and you had an x value here, you'd be able to predict where it will fall on the y value as well. And what this can do is we can actually somewhat predict many things, diseases, types of diseases, where diseases potentially can occur. This is what regression is kind of telling us, is that if we have this line, we have this fitted line, so to speak, and we have a value, where is it going to fall? You know, what is going to be our y value here? And we can do this for multiple things. You can compare multiple data points to each other, and we can use regression to kind of tell us if you're given a value where it's going to fit on the line. So equations to calculate a and b. So we're trying to predict y, right? We're equaling y hat here. So we have to find a and bx. Well, b is equal to r times s of y, standard deviation of y, divided by s of x, the standard deviation of x. And that's your b, and a is going to equal your y bar, so the average of y values, minus b times the x bar. And that'll be your a. So a plus then b of x, the x values given to you, what is going to be your y hat, the predicted value of y. So here we have the components of a regression model, where slope b is the key statistic produced by the regression. So when we have our equation of y hat equals a plus bx, this gives us our line. And then b is the slope, is the change in y per unit of x. Well, this is going to be in 1 unit. So when you figure out b, this is the slope, this is the change in y per unit of x. A, as the intercept, tells you at what point does this line cross over the y-axis, right here. So regression line, illustrated example. So for this illustrated example, we have established that x bar equals 603.64, y bar equals 20.55, with our standard deviation of x, standard deviation of y, and our r value. This is what we've calculated in the previous videos. So to determine the slope coefficient of b, take r multiplied by our s of standard deviation of y over the standard deviation of x equals 0.737 times, right, so that's your r times, here's your s of y, s of x, and you're going to get your value of 0.02283. Remember, that's going to equal your b. And the intercept coefficient a is equal to y bar minus b times x bar, which equals 20.55 minus 0.02283. Remember, here's your b value, times your x bar, and you're going to get a value of 6.77. Now to find where it fits in the regression model of y hat here, you take 6.77 plus 0.0228 and multiply that by your x. So you find your x point, and once you plug in a value for x, it'll predict where it's going to land for your y bar, or y hat. Remember, x, y with our graph here. Okay, so here's the output from SPSS. So if you were to look at it, so you look at it, here's your b, and it gives you your standard error, and then beta coefficient, your t, and the significance of your t value. Shown here, and then that is going to conclude our slide. So this is what you do, and if you ever need to have your predicted y hat value, once again, you just plug the value in for x. Once you figure out your b and a for your slope, and then you'll be able to determine your y hat there. So once again, regression can go even deeper, and you can do many things with regression. For right now, we really just want to focus on knowing the formula for how to get your y hat for your predicted value of y. So knowing the formulas for b and a, and then knowing that when you have your b and a, that b is the slope and it's the change in y per unit, a is the intercept, and what you're doing is you're being able to predict, given an x value, where it would land on this slope within this line. Okay, and then correlation, just finding our r value. So that is what we're going to know for now. The book does go into more, and you can definitely read it to maybe have a better understanding, but for the purposes right now, that's all we're going to cover for this week. All right. If you have any questions, please let me know. If not, have a great day, and I'll